So let us start. Physical properties of alkyl halides. Okay. In last video we have seen methods of preparation of alkyl halides. Now we are going to discuss some physical properties of alkyl halides. Okay. So first see nature of intermolecular forces. Okay. Now see, we have studied in 11th standard. We have studied periodic table. Okay. There we have studied that halogens are more electronegative than carbon. Okay, halogens are more electronegative. That means they pulls electron crowd towards itself. Okay, and if we compare halogens like fluorine, bromine, and iodine, these halogens, electronegativity of this halogen is greater as compared to carbon. Okay, so as a result, what happened in this bond between carbon and halogen? Halogen being more electronegative, it pulls electron crowd towards itself. Okay, it pulls electrons towards itself. So partial negative charge is developed on halogen. Okay, and carbon atom bears partial positive charge. Okay, so here you can see there is a charge separation. Halogen possess partial negative charge and carbon possess partial positive charge. Okay, and that's why this molecule of alkyl halide is polar molecule. Two poles are there, negative pole and positive pole. Understand? And that's why this bond is called as polar covalent bond. Okay, the bond present in between carbon atom and halogen is polar covalent bond. Why polar? Because there are two poles, charge separation is there, and reason behind polarity is halogen atom, which is more electronegative. It pulls electron crowd towards itself, and that's why carbon bears positive charge and halogen bears negative charge. That's why it is polar bond. Why covalent? The bond between carbon and halogen is formed due to sharing of electrons. Understand? We have studied covalent bonds. Covalent bonds are the bonds which are formed due to sharing of electrons between two atoms. Okay, so that's why it is covalent bond, and hence the bonding between carbon atom of alkyl group and the halogen is polar covalent bond. Okay, now let us see next point. Okay, now we have studied that size of halogen increases from fluorine to iodine. Okay, size of fluorine is smaller than chlorine, size of chlorine is smaller than bromine, and size of bromine is smaller than iodine. So iodine is greater in size and fluorine is smaller in size. So as we go from up to down, size increases, right? There is increase in size, and as the size increases, bond length also increases. The length of bond between carbon and halogen also increases. Okay, let us see how it increases. Let us see first what is bond length. Okay, we have studied in 11th standard that bond length is the distance from center of one atom to the center of another atom. Okay, so this is suppose center of carbon atom and this is center of fluorine atom. So this is called as bond length between carbon and fluorine atom. Okay, now as the size of atom increases, this distance will also increase, right? As the size of atom increases from fluorine to iodine, this distance, that means bond length, will also increases. So as the size of halogen increases, bond length also increases. Okay, then what about bond strength? What will happen when bond length will increase? Bond strength will also increase or decrease. We have studied in 11th standard that shorter bonds are stronger than the longer bonds. Okay, so as the bond length increases, bond strength decreases. Understand? Okay, so if we see halogens from fluorine to iodine, size of that atom increases. Understand? Bond length between CX also increases. Okay, and as the bond length increases, bond strength decreases. Okay, now you can see this table number 10.2 which is given in your textbook. Bond parameters of CX bond they have given. Okay, now see, here are they have shown bonds. CH3F, CH3Cl, CH3Br and CH3I. Okay, and you know size of halogens increases from fluorine to iodine. Okay, so I have told you as the size increases, bond length also increases. So you can see size of fluorine atom is smaller. Okay, so the bond length between carbon and fluorine is 139, and as we move down you can see the bond length is increasing. See, carbon fluorine bond length is 139, carbon chlorine bond length is 178, and carbon bromine bond length is 193. Iodine is the greatest in size in halogens. So carbon iodine bond length is 214, and as a result you can see bond enthalpy decreases, bond strength. Okay, enthalpy of that bond or heat of that bond decreases. Shorter bond, more enthalpy, and longer bond, less enthalpy. Okay, and dipole moment also decreases. Okay, shorter bond has higher dipole moment and longer bond has smaller dipole moment. Okay, so these are the bond parameters of carbon halogen bond. Now let us see next physical property, that is boiling point. So let us see boiling points of alkyl halides. Okay, if we compare the boiling points of alkyl halides and the boiling points of corresponding alkanes, you will find that the boiling points of alkyl halides are higher than those of corresponding alkanes, and the reason behind it is higher polarity and higher molecular mass of alkyl halides. Understand? Molecular mass and polarity of alkyl halide is greater as compared to alkanes, and that's why the boiling points of alkyl halides are greater. Okay, so let us see the order of boiling points of alkyl halides. Okay, boiling point of alkyl halide decreases in following order. Boiling point of alkyl iodide is greater than alkyl bromide, which is greater than alkyl chloride, and which is greater than alkyl fluoride. Okay, so this is because of higher polarity and higher molecular mass. Molecular mass of alkyl iodide is greater than this. Okay, and alkyl fluoride has lower molecular mass, and that's why the boiling point of this compound is greater as compared to remaining three. Okay, you can see here haloalkanes are given over here: methyl fluoride, methyl chloride, methyl bromide and methyl iodide. Okay, so alkyl group present in all these compound is same, methyl group is there, but halogens are different. Here iodine, bromine, chlorine and fluorine. Okay, so what I told you, as the molecular mass increases, boiling point also increases. Okay, so molecular mass of this compound is greater as compared to these three, and that's why the boiling point of this compound is greater, 315.4, and that of alkyl fluoride 194.6. Okay, and see here alkyl group present in all these four compounds is same. That means molecular mass of alkyl group is same everywhere, but the molecular mass of halogen is changing. Here fluorine, chlorine, bromine and iodine, and you know molecular mass of iodine is greater, and that's why the boiling point of alkyl iodide is methyl iodide is greater as compared to methyl bromide, which is greater than methyl chloride, which is greater than methyl fluoride. Understood? There are some more reason because of which boiling point increases or decreases. Let us see those. Here you can see, as the number of carbon atom in that alkyl halide increases, boiling point also increases. Okay, now here you can see halogens are same, chlorine, 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 chlorine. Okay, but number of carbon atoms in every compound are different. Here only one carbon atom is there, here two carbon atoms are there, here three are there, here four are there. So as the number of carbon atom in that alkyl halide increases, boiling point also increases. Okay, here also same reason is there. As the number of carbon atom increases, molecular mass will increase. Okay, if you see the molecular mass of this hydrogen molecular mass is 1, so it is not its contribution is less in the total molecular mass of that compound. Okay, let us see, carbon has molecular mass 12. Okay, then 3 hydrogens are there, that means 3, and chlorine has 35.5. Okay, so what is the sum? Sum is 50.5 is the molecular mass of this whole compound. Okay, then in next compound, carbon atoms will increase. Here 2 carbon atoms are there, so this 12 will become 24. Okay, so again molecular mass will increase. Here 3 carbon atoms, molecular mass will increase. Here 4 carbon atoms, molecular mass will increase. Okay, so as the number of carbon atom in that particular alkyl halide increases, boiling point also increases. Understand? Boiling point increases. Then one more factor is there which affects the boiling point. Now in isomeric alkyl halides, isomeric means what? Same molecular formula but different structural formula. Okay, so in isomeric alkyl halides, boiling point decreases with increase in branching. When branching or branches increases, surface area decreases, and that's why boiling point also decreases. Okay, so see here, these are isomers of each other. See the molecular formula, how many carbon atoms? 1, 2, 3, 4 carbon atoms. That means C4. How many hydrogens? 3 plus 2, 5. 5 plus 2, 7. 7 plus 2, 9. That means H9. Okay, and halogen is same everywhere, that is bromine. Here also you can see 1, 2, 3, 4 carbon atoms. Then 3 plus 1, 4. 4 plus 2, 6. 6 plus 3, 9. Means hydrogens are 9 and bromine is there. So in all 3 compounds, molecular formula is same but their arrangement is different. Understand? And that's why they are isomers of each other. Now what I told, as the branching increases, surface area decreases. Okay, as the branching increases, surface area decreases, and as the surface area decreases, boiling point also decreases. In first example you can see no branching is there, straight chain compound is there. Okay, so the boiling point is 375. Here only one branch is there. Okay, so branching is present over here, so boiling point decreased. Again here you can see more branching is there in this compound, so again boiling point has decreased. Understood? So there are 3 factors. First is molecular mass increases, boiling point also increases. Then number of carbon atom increases, boiling point increases, and as the branching increases, boiling point decreases. Understood? So this was about the boiling point of alkyl halides. Now let us see next point, solubility. Okay, let us see solubility. Next physical property of alkyl halide is solubility. Okay, we have studied that alkyl halides are polar molecules, but then also they are insoluble in water. You know water is polar molecule. Okay, and we have studied that polar substances or solutes dissolve in polar solvents. Okay, but here alkyl halides are polar and water is also polar, but then also alkyl halides are insoluble in polar. What is the reason? See, alkyl halides are unable to form hydrogen bond with water. Okay, when any substance dissolve in water means what? It forms, see this is structure of hydrogen. Okay, so when we dissolve any, when we add any substance in water, that substance form hydrogen bond with water and they dissolve in water. But here alkyl halides are unable to form hydrogen bond with water, and that's why they are insoluble in water. Okay, and the attraction between, when we dissolve any substance in water or any solvent, there are 3 kind of interactions, right? 3 kind of interactions are solute-solute interaction, okay, or solute-solute attraction, then solvent-solvent attraction or interaction, then solute-solvent interaction or attraction. Okay, when the solute-solvent interaction is greater, then only that solute is easily soluble, readily soluble in that water. Okay, when solute-solute interaction or attraction and solvent-solvent attraction is greater than this kind of last one attraction, that time it is insoluble or less soluble in that solvent. Okay, so what happen in case of alkyl halide? The attraction between 2 alkyl halides is greater. Okay, they are strongly attracted towards each other, and that's why the attraction between alkyl halide and water molecules becomes lesser. Okay, that is weaker attraction. So here solute solvent interaction is not strong, and that's why the alkyl halides are insoluble in water. Understand? And these alkyl halides are soluble in non-polar organic solvents. Understand? Okay, alkyl halides are insoluble in non-polar organic solvents, and alkyl halides are insoluble in water. What is the reason? The reason behind it is alkyl halides are unable to form hydrogen bond with water. Then the attraction between alkyl halides to alkyl halide, okay, alkyl halide to alkyl halide attraction is stronger as compared to alkyl halide and water, and that's why it is insoluble in water. Okay, now let us see next. Now see, one problem is given in your book. Arrange following compounds in order of increasing boiling point. Okay, so compounds they have given: bromoform, chloromethane, dibromomethane and bromomethane. Okay, so see, bromoform, what is the formula? You know, formula of chloroform is, what is the formula of chloroform? CHCl3, right? So what will be the formula of bromoform? CHBr3 is bromoform. Then chloromethane, methane, CH3Cl. Okay, then dibromomethane. Okay, so here CH and 2 bromines are there, so that's why hydrogens are 2. So this is dibromomethane, and bromomethane means again CH3Br. Okay, so these 4 structures or these 4 compounds they have given us, and we have to write them in the increasing order of their boiling points. Okay, so let us write. See, in every compound you can see carbon atom is only 1. Okay, then here 3 bromines are there, here 1 chlorine, here 2 bromine, 3 bromine. We know molecular mass of bromine is greater than chlorine. Okay, so we have to compare first the compounds containing bromine. Here how many bromines are there? 3 bromines, here 2 bromines and here 1 bromine. Then the compound containing more number of bromine will have higher molecular mass. Okay, and higher molecular mass means what? Higher boiling point. Understand? So this CHBr3 will have higher boiling point. Then Br2, CH2Br2 will come. Then CH3Br. Okay, then chlorine, CH3Cl will be there, as chlorine has less molecular mass as compared to bromine, and number of carbon in all 4 compounds is similar. So no need to think about carbon. We just have to focus on the halogens. Okay, so this is the order, means according to their boiling points, increasing order of their boiling points. Understood? This kind of example they ask for give reason to arrange the order of boiling point, melting point. Okay, so when physical properties are that we have 4 lessons of organic chemistry in our syllabus. So wherever physical properties are discussed, so on those physical properties this kind of question will come. They will give you some compound, they will ask you to arrange in order of boiling points, in order of bond length. Okay, they will ask question on solubility, why this compound is soluble in water, why this it is not soluble in organic solvent. This kind of questions or give reason type questions will come on these physical properties. Okay, so here we have completed physical properties of alkyl halides. Okay, so let us stop here.